Hello again. Hopefully, you guys are doing okay and you made it through another week safe and healthy. Big thing we need to do for class this week is to review for the third test that you have in statistics. Just like everything else that we've been doing in class, this test will be online. And like the quizzes that you've done recently, it will be done through Google Forms, not directly through Canvas. There will be a link to the quiz that'll be in Canvas, or I will be sending out an email once it's posted, and you can link directly from there. So a few things about the test in general before I get into the specifics. This is roughly the same length as the previous tests that you've had, which means I would expect that for most of you it'll take an hour to an hour and a half. It might take slightly longer online than it does on paper, but my bet is for most of you it'll go pretty quickly. There is no time limit for the test. In Canvas, you can actually set things so it limits you to a specific time, but I really don't want that to be a factor with this test. The test basically is going to be like a bunch of little quizzes that are thrown together. From your point of view, it will be displayed on 18 separate screens, and I know that sounds like a lot, but what that does is it keeps you from having to scroll back and forth through things constantly. You're going to mostly have problems that go together on the screen at the same time so that you can refer to just those and then go on to the next part. You can go back and forth before you submit your answers, and sometimes that could be useful because you might find something later on in the test that gives you a clue of how to do a problem that you did earlier. And if you want to go back and change something, of course you can do that. Since this is an online test, it will be all short answer and multiple choice. Again, that's basically what you've been doing with the quizzes, so it should be a familiar format to you. I'm going to make the test available this Saturday, and you can submit it anytime before next Friday. Technically, next Thursday is the day it's supposed to happen, but you can do it whenever it's convenient to you next week. When you take the test, you will see a score immediately. You're not going to see the answers on the test, but you will see a score that the computer automatically gives you. I want to caution you, though, that your final score is likely to be higher than what the computer tells you it is. That was also true with the quizzes that you had for a couple of reasons. One of them is that a lot of things I will actually count as half wrong if you miss it, but that's not an option when I'm setting up the automatic scoring. It automatically takes off 1 point for everything. The other thing is that sometimes I can see that all that happened is you had like a little typo, and I forgot to put that possible typo in as an answer, and so I'll end up giving you credit for things that are right, but you just entered them wrong. So yeah, you'll get an idea of what's probably the lowest possible score you could get, but your final score is likely to be higher. Just like I did for the previous tests, I did post a sample test online. If you go to Canvas, you will find a PDF of questions that are like the things you'll see on test 3. There's also an answer sheet that goes along with those. The sample test is not in an online format, but it is there for you to practice with. And I'll also point out to you that you may use notes for the test. There's really not much of a way to stop that when you do an online format. And so, of course, you are welcome to do that. I do strongly encourage you to take the sample test ahead of time so that you have an idea of exactly what to expect and you know what you're doing with everything. There are two main topics that you need to know on this test. They're estimation and hypothesis testing. And we're going to go through both of those. For estimation, what I'm largely going to do to make sure that you have the ideas to you is I'm going to go through the questions that were on the estimation quiz that you took a week ago and just double check how you do everything with those. So you might remember from your quiz last week that you did have some questions that asked you what sort of interval you use for different purposes. And there's three kinds of intervals we learned about when we did estimation. We learned about z-intervals, t-intervals, and one proportion z-intervals. Z and t, those first two, you always use when you want to estimate an average, a mean of something. The difference between Z and T is Z is used for big samples, T is used for small samples. I said before, T for tiny is a good way to remember that. The difference between big and small in statistics is that to be big, you have to have more than 30 in your sample. So a Z-interval, you estimate the average of a sample more than 30. A T-interval, it's the average of a sample less than 30. One proportion Z-interval, what you're doing is you're estimating a percent. Proportion always means percent. One of the terms that came up with intervals was level of confidence. The level of confidence, or C level on your calculator, was basically how sure you were that your estimate was correct, how sure you were that the actual average or percent was going to be in the interval that you said. There were three main numbers that got used for levels of confidence: 90, 95, and 99. And since this was the chance you're right, the more important your research is, the bigger you want that number to be. If you were doing like scientific or medical research, you want to be 99% or more confident. There will be some questions on the test that are about the basics of how estimation works and how to use your graphing calculator to get estimates. And I'll remind all of you that pretty much everything that we're doing on this whole test in both of the chapters we've dealt with are in stat tests. And for estimation, it's all the things that begin with interval that you want to look for those. Now, on the side, I'm going to mention I had an email last week from one person in the class who, with the COVID-19 outbreak, had gone back to a different country that he is from and did not have access to a graphing calculator. If for some reason you don't, let me know and we're going to find a way to hook you up. There's a couple of ways that you can download a calculator so that you can use it on your computer or phone. And so just because you don't happen to have one, maybe you've been borrowing from the Success Center, we will make sure that you have a way that you can do your problems. So what kinds of questions might you be asked? Well, first off, I may ask you what the various variables that are on the input screen stand for. Remember that sigma, that thing that looks like a little O at the beginning of your input, means the standard deviation. And so on this problem that you're looking at on the screen, the standard deviation would be 3.5. X bar is the average or the mean of your sample, and here that's 98.6. Don't know if we're maybe measuring somebody's temperature here is what that kind of looks like. N is the number in your sample, and C level is the level of confidence. On the output screen, one question you might be asked is for the margin of error. And what you always do to find the margin of error is you take the top number from your interval, here that would be 99.501, and you subtract the middle, the average here, which is 98.6. So I'm going to subtract those two numbers, 99.501 minus 98.6. And on this problem, I'm pretty sure my margin of error is going to be 0.901. So when you did your quiz last week, you had a set of screenshots like what you're looking at here, and there were a wide variety of questions. One of them was, which of these had the largest amount in the sample? All I do for that is I look at the N that's in all three of those different tests, and on this one, those are 90, 12, and 493. 493 is pretty obviously the largest number, and so it's the one proportion Z interval that's going to have the largest sample. That's the one that used the most things. I also asked a question which was something like, which of these is the most likely to be right? Which of them would have the parameter most likely in the interval estimate? For that, what I'm going to look at is the C level, the confidence level, 95, 90, and 99. The highest number on that is 99, so once again, the one proportion Z interval, the last one, is going to have the highest confidence level. It's the most likely to be right. In your quiz last week, you had some questions where you were supposed to come up with some interval estimates. And I want to go through those just to remind you of what you do with them. On your test, you're also going to have some questions like that. You'll have at least one and probably a couple of each of the types of intervals that we learned about. So this problem, what it says is Blue Bunny is trying to estimate the average number of calories in their new triple fudge ripple ice cream. They take a sample of 15 servings of the ice cream and find the average number of calories is 422 with a standard deviation of 29. Use this information to find a 90% t-interval for the average number of calories in a serving of triple fudge caramel ripple ice cream. Now, one thing I'll point out that's true here, and it is also true on your test, is you'll notice it tells you directly which type of interval you need to do. This is a t-interval, and it will tell you that on the test too. It's going to say exactly which one you do need to do. The reason why we're doing a t-interval is we're estimating an average, and this is a small sample. It only has 15. But it will tell you which one you do have to do. So I go to Stat, Tests, and T-interval. I typed in the average is 422, the standard deviation is 29, and the number was 15 servings. It told us to do a 90% T-interval. That's why for confidence level, I put 0.9 or 0.90. On a TI-84, you actually could just type in 90 and that would be okay too. You do your calculation, and the best thing to do for your answer is just literally copy what's in the parentheses, 408.81 to 435.19. Now, I actually did a screen capture at the bottom that shows all the different things I put in for the computer to count correct as right answers. And on this one, you might notice that some of them have spaces between the parentheses and the comma, and some of them don't. It does tell you in the directions to write it as two numbers in parentheses separated by a comma. Generally, the best thing to do is don't worry about throwing in any spaces, or if you're entering a number, don't put like x equals, although I try to count all the possibilities that you could have when I do enter things in the computer. Again, I'll go back and look at what you put, and if it does look like there's something that should have been counted right, I'll count it right. But yeah, here it's between 408.81 and 435.19. The next one that you had in your quiz last week talks about how many kids are in kindergartens in Iowa. And this one, it tells you to do a z-interval. So you go to z-interval. And here the standard deviation is 3.9. The mean for the samples is 19.1. The 99 for N comes from the fact that it's one in each of 99 counties, so that's why it's 99 for the number. And the confidence level is 99%, so 0.99. And here, what I would do for my answer is just copy down 18.09 to 20.11. The next question is also asking you to find an interval, but it was phrased just a little bit differently. This time it's asking you to do a one proportion z interval. And so first of all, to do the test, you go to one prop z int. And when you type in your numbers, it is important that you get the order of them correct. In the question, it says a survey of 783 teenagers in Des Moines found that 602 frequently texted while driving. Now, if you look at what I actually typed into that input screen, I put X is 602, and N is 783. The important thing is that the smaller number has to come first. It's 602 out of 783. And you need to sort that out and think which one's which. Confidence level's 90%, and I go to calculate. Now, the question that it asks is which of the percentages is not part of the interval estimate? Well, if I look at the parentheses, this is basically telling me that my estimate goes from 74% to 79%, from 0.74406 to 0.79362. Well, 75, 77, and 79 are all in there, but 73 is just a little bit too small, and that's why 73 is the right answer. It's not in the interval. The other thing we did with estimation problems were sample size, figuring out how big of a sample you needed to get the required results. And I will tell you that of all the things on the quiz last week, this is what most of you had problems with. And there are a couple of things that typically go wrong with these, but I want to point out to you what's up with them. So the first question that we have here, it says you want to estimate the average age of family doctors in the United States. Preliminary survey shows that the standard deviation appears to be 7.3 years. How many doctors would you have to include in your sample to estimate that average age within 3 years? And it tells us we need to use 98% confidence. Well, the formula that you need is given on that quiz. It will also be given on the test. In fact, you're going to have basically the exact same set of screenshots on your test that you had on the quiz. So the formula is written up there where it says N equals ZC times S over E squared. What you need to realize is what all those variables stand for. ZC means the Z-score that goes with the confidence level we have. Problem talks about 98% confidence, so I go to that little table and it tells me that the Z-score is 2.33. Then I take 2.33 times the standard deviation, which was 7.3, and I divide by the margin of error, which the dead giveaway word for that is always within 3 years. Work all of that out and I square that and my calculator tells me 32.1. Now the number one thing that goes wrong, and the multiple choice answers were expecting this, is that remember you always round up. Here, the answer we get is 32.1, but the right answer isn't 32, it's 33. You round up to the next whole number. That's because 32 would not be quite enough to get the results we want, but 33, it's more than enough. So 33 is the right answer. That's the number one thing that went wrong, and a whole bunch of you did that on the quiz that you had last week. The other thing that typically goes wrong is people forget to square. They just do the multiplication and division, but they don't square, and if that happens, you get a much smaller answer than you're supposed to. So yeah, here you can see how to do it right, and the right answer is 33. The other set of problems that you had dealt with estimating percents and how many you'd need for samples there. This next problem, a recent national survey said that 9% of Americans use Twitter daily. Suppose you want to see if the percentage of high school students that use Twitter is higher than that. How many students would you have to sample to estimate the percentage of high school students who use Twitter daily within 4% either way with 95% confidence? So it says, first of all, 9% use Twitter. And if you look at what I typed into the calculator, the first thing I put was 0.09. Anytime it gives you a percent, you've got to write that as a decimal in the formula. So 9% is 0.09. The next thing I typed was 0.91. And what the P and the Q that come up in that formula at the top are basically the percent yes and the percent no. 9% do use Twitter daily, 91% don't use Twitter daily. You just subtract from 100, and again, both of those are decimals, so 0.09 times 0.91. Then in parentheses, I looked up that 95% confidence the z-score is 1.96, divided by, and it says within 4% either way, so divided by 0.04. It's just the parentheses that are squared, and that's why I do basically type it in exactly like it looks in the formula. Again, I round up. This one you probably would have anyway, but the correct answer is going to be 197. And there's one more sample size question on these. This next one, it says that you have no idea ahead of time what this percentage might be. Whenever you have no idea, no preliminary estimate, the P and the Q that go into that formula always end up being 0.5. Basically, you're assuming it would be 50-50 because that's the worst thing that could happen. So you put in 0.5 times 0.5. For 90% confidence, the z-score is 1.645. It says within 2%, so divided by 0.02. And again, I square what's in the parentheses. Once again, you got to round up, and that's why the answer is going to be 1692. So again, with estimation, you want to make sure that you know just the basics of what the variables mean and how to type things into your calculator. You want to be able to do each of the types of tests, a z-interval, a t-interval, and a one proportion z-interval. And you want to be able to estimate sample sizes for both an average and for a percent. You'll have at least one and probably a couple of each of those types of problems that you need to work out for the test. The second main topic that comes up on the test is hypothesis testing, what you need to do to figure out whether things are significant. So since we're trying to figure out whether things are significant, something that's important to know is just what significant means. And the important thing in statistics is significant means that something was unlikely to happen by chance. You have that question like word for word on your quiz this week, and it also is pretty much there word for word on the test. Significant means it didn't happen by chance. And just like an estimation, one thing you will have are some questions that go through the basics of how hypothesis testing works. One of the key things that comes up with hypothesis testing is the term level of significance. The variable that goes with that is the Greek letter alpha, that sort of fish-shaped thing that's down at the bottom left on your screen. And what the level of significance is basically how willing you are to be wrong when you do a hypothesis test. Literally, it is how willing you are to say that something's significant when really it did just happen by chance. And along with that, you'll see some questions where it asks you what would be an appropriate level of significance to use. This is basically the opposite of the level of confidence you did with estimation. Level of significance should be a small number because it is the probability you're going to be wrong. And so the more important your research is, the smaller that number should be. And typically, the numbers that get used are things like 10%, 5%, or 1%, 0.10, 0.05, 0.01. And important research, 0.01 is what you want that number to be. The other number that goes into a hypothesis test is what we call the p-value. And the p-value is the actual probability that a result just happened by chance. The alpha, the level of significance, is how willing you are to be wrong. The p-value is the actual probability that you're wrong. You compare p with alpha, and the way you tell whether something is significant is that the p-value should be less than the level of significance. You'll have a couple of questions that ask you about alternative hypothesis and null hypothesis. And this actually is probably one of the good things about doing your test online. If it were on paper, I'd probably make you write out alternative and null hypotheses. But here it's just going to give you some situations and ask you what would those be. For instance, here's a problem where you might be asked to figure out what's the alternative hypothesis and what's the null hypothesis. And it's a fairly lengthy problem. It says a 2017 study asked people of different political backgrounds who they felt was the greatest president in American history. Even though he was the first Republican president, only 48 of 146 Republicans felt Abraham Lincoln was the greatest president. However, 72 of 155 Democrats felt Lincoln was the greatest president. Was the percentage of Republicans who chose Lincoln as the greatest president significantly lower than the percentage of Democrats who did use a 2-proportion z-test at the 0.05 level of significance? So when you see a question that's asking you about the hypotheses, the real point of that question is what do you have to focus in on to figure out what your answer is going to be? And what I told you before is what you want to do is look at the actual question. You could ignore all the background information, but look at the actual question. Here, the question says, was the percentage of Republicans significantly lower than the percentage of Democrats? To find the alternative hypothesis, the H1, I just turn that around and make it a statement. So I say the percentage of Republicans who chose Lincoln as the greatest president was significantly lower than the percentage of Democrats who did. Basically, Republicans were less than Democrats is what we're saying when we do that. Now, you're going to see that phrased basically as multiple choice questions, so you just need to recognize which of those was. But again, alternative, it's just whatever the question says, phrased as a statement. And basically, all you do for the null hypothesis is you take that alternative and you toss in not. So here, the percentage of Republicans who chose Lincoln as the greatest president was not significantly lower than the percentage of Democrats who did. Same statement, except we've negated it. We've thrown in not into our statement. So once you get done figuring out what the alternative and null hypotheses are, you're going to have some questions that ask you, how do you do them? What do you put on the screen in your calculator to do these tests? When I do these as paper tests, what I typically do is I'll just put a little picture there and tell people to write in exactly what you put for all the different variables. I can't do that quite as easily online, but you're going to essentially do the same thing. I will ask you what each of the variables equals, and you need to type in the appropriate number. So I just want to go through quickly what everything is. Remember that mu0 is what the average is supposed to be. It's like the average of the population or the average of what it's been in the past. It's usually the first number that's given in the problem, but it is what the average is supposed to be. X bar is the actual average from your sample. Sx is standard deviation, so is that sigma that I did back when we were doing the z earlier. N is the number in your sample. You will have questions about that greater than, less than line that you have. Remember, you look at what the question says and you choose whichever thing is appropriate there. We're going to look at some examples later on to sort those out. I also have a screenshot of a 1-proportion z-test, and again, the big thing to remember there, P0 is what the percent's supposed to be entered as a decimal, and X is always smaller than N. It's like how many have a characteristic out of how many total. Well, there's lots of stuff to enter. I actually think doing a 2-sample t-test is one of the easier things to do because the things are basically telling you what they are. We have the average, the standard deviation, and the number from the first sample, and then the average, the standard deviation, and the number from the second sample. The one thing that's kind of weird on these is remember on that line that says pooled, you always want to choose yes. Probably by now your calculator is set to default to that, but yeah, pooled should be yes. I'm going to go through one example of each of the types of tests that we've done just to remind you of how everything works. So a z-test, it says a nationwide study in 2015 found that the average middle school student spends 127.2 minutes per week doing homework. The standard deviation was 38.4 minutes. Suppose 74 students at a middle school are surveyed and it was found that they do an average of 115 minutes of homework each night. Do a one sample z-test. Again, the type of test is given to you at the 5% level of significance to see if this is significantly less than the national average. The important thing to do is to figure out which number is which when you go through any sort of a test. And you'll notice I use different colors to kind of make those jump out and see what's up with it. First thing it tells us is we had a nationwide average of 127.2. And then we have a standard deviation of 38.4. They surveyed 74 students and they found an average of 115 minutes. And we're supposed to do a z-test at 5% level of significance. What I've got to do is turn those numbers into the problem into the things that I put on the screen. And if you look through this, we had the nationwide average of 127.2, so that's that mu0 that goes on the first line. The standard deviation is 38.4. The average for my sample is 115. And the size of the sample was 74 students. Finally, it says, is this significantly less than the national average? That's why we highlight less than on that next to last line. Down at the bottom, you see what the results screen looks like for this same problem. The very last questions that you'll be asked often will say, what's the p-value? And here, I would accept a range of answers, but what I would probably put is 0.003. And then finally, every one of these questions is going to basically say yes or no, is this a significant result? And what you always do for that is you look at your p-value, 0.003, and you compare that to the level of significance. We had a 5% level of significance. If the p-value is less than that level of significance, then yes, it is a significant result. And 0.003 is definitely less than 0.05, so this one is yes. So here's another example. According to AAA, the current average cost of a gallon of gas in Iowa is $1.45, which is like a buck less than it was not that long ago. A survey of 6 stations in Des Moines found an average price of $1.49 with a standard deviation of 5 cents. Do a one sample t-test at the 1% level of significance to see if gas in Des Moines is significantly more expensive than in Iowa as a whole. Again, the trick to the problem is taking the numbers in the problem you're given and figuring out which one goes where when you enter them in the screen. But we were told that all over Iowa, the average is $1.45. So 1.45 is the mu0. In Des Moines, that average was 149, and the standard deviation is 5 cents. And they looked at 6 stations in Des Moines. So there's my next 3 lines. The question is saying, is gas more expensive in Des Moines? That's why greater than is highlighted for this test. If I were asking about the p-value, this time it's like 0.05367. And again, I would accept a range of answers. Probably I'd accept 0.05 perfectly well for that one. The question ultimately is gas significantly more expensive in Des Moines than in Iowa as a whole? Here I compare 0.05 to my level of significance, which would be 0.01 or 1%. This time it's more. To be significant, it's supposed to be less, and that's why no, this is not a significant result. So probably gas in Des Moines costs about the same as it does elsewhere in Iowa. I tried to purposely choose examples that are different from both what's on your quiz and what's on the sample test so that you could get as much practice as you could with different things. This one, it says, according to the U.S. Department of Education, 13% of all students in the United States receive some form of special education services. At one area high school, 38 out of 263 students receive special ed. Is this significantly higher than the national average? And it says use alpha equals 0.05 to do a 1 proportion z-test. And here I've got basically everything typed out and showing you what the screens are for the whole rest of the test. The average nationwide was 13%, and I do remind you again, percents you always have to enter as decimals, so I put 0.13 on the calculator. And then 38 out of 263 in our local school. And then the question is it higher than the national average? So greater than's highlighted. The p-value here is about 0.242. That's definitely more than 0.05, and that's why this is not a significant result. Two more quick examples we're going to look at. This one says, on a TV cooking competition, different judges rate dishes prepared by celebrity chefs. Each judge can give a total of up to 20 points. Suppose the three judges give an average rating of 17.3 to one chef's food, with a standard deviation of 2.6. The same three judges give an average rating of 17.7 to the second chef's food, with a standard deviation of 4.3. Did the judges rate the first chef significantly lower than the second? We're supposed to do a two-sample t-test at the 5% level of significance. So what sometimes happens, especially on these two-sample t-test problems, is people just sort of get lost in all the numbers and they find it hard to sort out what goes where. But honestly, these are really about the easiest ones to figure out because the first half of the problem tells you about the first chef, and the second half of the problem tells you about the second chef. There is one number that really doesn't matter at all, and that's the fact that they could give a score up to 20. And you just basically ignore that and look at the average, the standard deviation, and the number for each of the chefs. So I cut off what doesn't belong here and just highlighted again the stuff for the first chef and the stuff for the second chef. The average for the first one is 17.3, the standard deviation is 2.6, and the number is 3. For the second chef, the the average is 17.7, the standard deviation is 4.3, and the number is 3. The question says, was the first chef significantly lower than the second? And that's why we've highlighted less than. Again, on the two-sample t-test, you always want that pool to say yes. So you just make a quick set to make sure, yeah, all of those numbers are what they're supposed to be, and then you'll hit calculate. You want to realize that p-value can be a wide range of scores. We had some that we were doing before where the answer went into scientific notation, and you had really, really tiny numbers. This one is a really, really large number. It's 0.4485, which basically means that there's a 45% chance that we're wrong if we say this is significant. And that's a pretty big answer. It's definitely way more than 5%, and that's why no, there is no way that this is a significant result. For our last example, I'm going to go back to the problem I was doing to find hypotheses earlier, where our question is trying to say, was the percentage of Republicans who said Lincoln was the greatest president significantly lower than the percentage of Democrats who did? Now, if you look through the problem, they tell us the rest of what we need to know, which is that for Republicans it was 48 out of 146, and for Democrats it was 72 out of 155. I've highlighted those numbers in different colors here, and I also highlighted that lower is what we're trying to figure out. So again, you see x1 is 48, n1 is 146, x2 is 72, n2 is 155, and we want to know, are the Republicans less than the Democrats? So that's why less than's highlighted. Once you hit calculate, here the p-value is 0.0081. And we're comparing that to the 5% level of significance. Well, this was be less than 1%, so it's definitely less than 5%. And that's why, yeah, there is a significant difference between Republicans and Democrats. Yes, this is a significant result. So I'm not quite done with the PowerPoint, but that is what you need to know for your test. Again, with estimation, you want to know the basics, and you do want to know how to do a z interval, a t interval, a one proportion z interval, how to figure out the sample size you need for averages and the sample size you need for percents. For hypothesis testing, you want to make sure that you know the basics of that, especially things like what significant means, what's the level of significance, what's the p-value, how to find the hypotheses, and how to compare your numbers at the end of the problem. And then you'll have some z-tests, some t-tests, some one proportion z-tests, some two sample t-tests, and some two proportion z-tests. So you're going to have at least one of everything that you need to actually work out and figure out whether the results are significant. I want to talk about how you will probably want to budget your time over the next couple of weeks. This week, you do have a quiz that's online about hypothesis testing. So yeah, there is a quiz this week that you need to take, and if you haven't taken it yet, that may actually be a good thing because I just went through again how hypothesis testing works, and that may help you with that quiz. Once you're done with that quiz, the big thing you're going to want to do is to study for the test so that you can take that test and hopefully do well on it. There will be another video that's online this week that goes through some examples of correlations, which is the next key topic that we're going to do. There are 2 or 3 of you that I actually suggested for your project may want to do a correlation R test, and that'll be leading into what that is. So you're going to probably want to take a look at that video, although there's not really much of anything we're going to do like assignment-wise yet with that. That'll be coming up in the future. Next week, you will want to take test 3. That'll be the main thing that you do next week. Then I'm going to be putting online next week the main part of the notes about correlation and regression. That's actually chapter 9 in your book. So that will be when I would really want to look at most of it. The video I'm putting up this week is a short one that just goes through a bunch of examples. Next week's when we're going to get into the main part of how do you do it and, what do you have to know about it. Then 2 weeks from now, you're going to have a quiz over correlation and regression. That's why once you got the test out of the way, you do want to get to work figuring out how does that work. So hopefully that gives you an idea of what you need to know for the test. And I'm not real thrilled with doing tests online, but it's what we got to do under the circumstances, and we will make the best of it. I do wish you well with that. Hopefully the test will go well and you'll be good to go with where we're at after that. Have a good week, everybody.